Okay, so we're going to verify the solution for each of the inequalities that are given, and if they're incorrect, then we'll write the correct solution. So we've been given x minus 12 is less than or equal to 20, and we've been given a solution that x is less than or equal to 32. So if that's our solution, let's start by checking our boundary point. Let's see if it works. So we're going to substitute our boundary point of 32 in for x in the original inequality and see what happens. So the left side was x minus 12, right side is 20. Let's substitute 32 in. So 32 minus 12 becomes 20. And left side and right side match. So we've got a true statement. So our boundary point is correct. So that's good. So now we need to check that the inequality sign, the less than symbol, part of it is correct. So we're going to check using a number that is less than 32. So we're going to use let's use 0 as indicated here. That is less than 32. So if we use 0, 0 minus 12 is negative 12. And negative 12 is less than 20, so we've got a true statement. So that's good. So if that is true, then we know that x is less than or equal to 32, and that is correct. Yes. All right, let's have a look at part B now. We've got a different inequality. Negative 5 times x is less than 30, and we're being told that the solution is x is less than or equal to, or less than negative 6. So, because it doesn't say that it's less than or equal to negative 6, checking the boundary point is not going to be very useful to you, because it will provide an answer that is not right. So we're going to check a number that's less than 6. Let's do that. So let's start with, let's go with negative 10. That's less than negative 6. So we're going to take our original equation. This is my left side. This is my right side. And negative 5 times x is the left, and 30 is the right. Let's substitute in a negative 10 for x. 5 times 10 is 50. Negative times negative is positive. So, is 50 less than 30? No, it's greater than. So this is a false statement. So the solution is not correct. So in order to find the correct solution, we can test a point that's greater than negative 6. We could test 0. Let's check it. Left side, right side. Negative 5x is the left, 30 is the right. Let's see what happens when we substitute in 0. We get 5 times 0 is 0. Is 0 less than 30? Yes, it is, so that looks like it's correct. Now, we should probably confirm that the boundary point is even correct, because we have not checked that. So, take the original inequality, and we're going to isolate the variable. We're dividing both sides by negative 5 to get rid of this negative 5. When we do that, we're left with x on the left. 30 divided by negative 5 is negative 6. Okay, so x and negative 6. So negative 6 does look right. It's the right boundary point. But we've divided by a negative, so we have to rotate our sign around. So x is greater than negative 6. So as we tested with 0, we suspected that it was correct, but we were assuming that our boundary point was correct. We hadn't actually checked that. Doing the quick little calculation with the original inequality does confirm that x is greater than negative 6.